Hey guys, a lot to go through right now. We're working in section 8.7 and we're working on a few pieces here about how to actually use complex numbers. And one of the things that I have to point out here is that I is equal to the square root of -1. Okay, without that, you're going to have some difficulties to see what's going on. Okay, so I've done a couple examples here, and like I said, I got to keep these like around 5 minutes, so I'm going to go a little quickly. Okay, so the first problem is simplify using I notation as needed. So as you can see right here, I wrote the original problem. I then started to make my steps, right? So I wrote my first, then my second, then my third, my fourth, my fifth, and finally my last step. So in step 2, I decided to separate or factor out the -1 from the 343. That produces the square root of -1. The square root of -1, as we indicated up here, is what? I. So now we replace that or substitute I for the square root of -1. In step 3, I then went and factored 343, found the perfect square in step 4, which was the square root of 49. The square root of 49 is 7. The square root of 7 is 7. And I just carried everything else through. When I multiply everything together, -2 times 7 is -14. I with the square root of 7. So the essence here is to understand that we are dealing with a number that really shouldn't exist, and we're going to go into more detail in the lecture itself, but these are just worked out problems. The second problem I worked out here dealt with a product, and I had to multiply the square root of -8 times the square root of -11. Now, if you see the steps that I have here, there's a lot of steps to make sure everybody understands, but in the first step, I just rewrote the original problem. In step 2, I factored out the square root of -1 from both of the other roots. I then began to look for perfect squares, right, in step 3, because 8 is 4 times 2, and 4 is a perfect square. Then I simplified, right? We know that the square root of -1 is I, so the square root of 4 is 2, so we have 2I times the square root of 2 times I root 11. When you multiply those together, you notice that you get an I squared. Now, let me point you down here in the highlighted section that when you are squaring I squared, you actually get -1, right? It should be the absolute value, it should be 1, but yeah, I know, it's kind of interesting, right? And we're going to go through those rules a little later. Probably not in this lesson, probably in the major lesson. So once we found out that I squared is -1, I just did the substitution here, and in step 6, found out that we had -1 times 2 times the square root of 22, which then just once doing the product, you get -2 root 22. All right, the next question we have here is a combination. Again, we've got a base combination. We have the quantity of 8 plus 3i minus the quantity of -5 minus I. Now, just so you know, this is the general form for a complex number. So this is a complex number. Now, I'm just going to rewrite the problem in step 1. Step 2, I'm going to do the distribution. And step 3, I'm going to combine like terms. That's it. You're just doing apples and apples, oranges and oranges. All right, in the last problem, I have 2 cases worked out for you. And I started off with the original problem saying multiply, okay? Multiply the quantity 4 plus 3i squared. So in case 1, I used classic multiplication, and you notice that I'm just doing the regular multiplication like 15 times 13, right? I'm doing the same process. So 4 times 4 is 16, 4 times 3i is 12i. 3i times 4 is 12i, and 3i times 3i is 9i squared. Well, we remember that I squared is -1. So I just changed the positive here to a negative, did the combination 16 minus 9, so our answer is 7 plus 24i. In case 2, I used our little cheat method, and it's by using the binomial expansion theorem, which you really haven't looked through yet, but we have done a little bit with Pascal's triangle, and we have done this with factoring. So I figured I'd remind you a little more about factoring. I labeled 4 as A, indicated in red, and I labeled B as 3I, labeled in purple. Now, if you look up here, that I just made a couple asterisks, actually 3, you'll notice that we have the factored form, the quantity a plus b squared, and we have the expanded form, a squared plus 2ab plus b squared. So I'm going to use this formula, if you will, and then I'm just going to substitute the values in. And that's all I did. I just subbed, right? And then I combined like terms. And because it's a nice square, you notice that both of these two things are the same darn thing. Okay? So 2 different ways of looking at it. You could also do the regular distribution, but that's also classic multiplication. So it's up to you. I hope this helps. We'll talk about it in the live stream. Let me know if you have any questions. Thanks. Bye.